Well, we'll get started. A couple minutes late. Everyone's milling in. I really do appreciate you all being here. 8 a.m. Friday morning. We're going to talk about building readiness and reopening, guidance and some case studies. So some of these are going to be pretty quick slides just to make sure that we're all on the same page. Copyright, the course description, which you all read. That's why you decided to come here this morning. The learning objectives. This is to really get the AIA certification so they can give you the PDHs. Do make sure to check in on the app so you can actually get your certificate. But this is the agenda for today. So we're going to touch on transmission really briefly. I'm going to talk about the ASHRAE Epidemic Task Force. Fortunate enough to be a voting member of the task force, lead the building readiness team. I've been heavily involved, but I'm going to try and skim over where the core recommendations are today, talk about a few items that people are still misquoting, do a little systems evaluation, and then really touch on some example projects and go from there. So right out of the gate, I'm going to make you think. Hopefully you've had your coffee. We don't have buzzers. You can't reach under your seat and do the poll, but please keep the answer in your head, which is, which path is considered the largest for SARS-CoV-2 transmission? Everyone got their answer locked? Great. It's A, airborne. Hopefully we're all there. But we're going to touch on some things, and I'm going to go a little bit chronological from when studies came out. This is one of the early ones. We've all seen it. Guangzhou restaurant in China. Hugo Lee did a research paper on it, right? And in essence, people got sick, but they've got the little wall-mounted units and the air just circulated, but the people in there only got sick that were in that air path, right? So does HVAC play a part? In this case, yeah, because these air currents really, in essence, generated it. So there's a whole video that goes along and distances, and this was really early on. The next one that really came out that was talking about HVAC was a study by University of Oregon, Institutes of Health. The building on the picture on the right, the units are up here, so you can see a lot of duct run. It's a healthcare facility. It was active. MERV 10 pre, MERV 15 final, and they actually had zone dampers. And they found virus at each one of those locations, even downstream of the MERV 15. Now, they weren't testing for viability of the virus, so this is one of those where we have to figure out, is that, they're doing more research. But it's showing that for an HVAC system, it is getting back to the unit, but is it getting back to the space and actually potentially infecting individuals? The next one is from University of Florida. They were doing a study. This one, I think some of it was more so to debunk the myth of 6 feet. You can see that they had infected patients and they were taking measurements of viable virus, meaning you can get infected by it. 4.6 meters. Drew, that's what, 15, 16 feet, right, bud? There we go. So, but in essence, so that you're now looking at a distance greater than that. Another study came out. This one's in a restaurant in Korea. What's really cool about this one is they actually had video cameras and time date stamp, so they could see how long people were in the space. They could see their interaction. This individual up here was the one that was the sick individual. You can see these blue are the air conditioning units. This air path, the other individuals that got sick, one person was there for 5 minutes, one person was there for 20 minutes, right? So that whole 15-minute thing, is that real? But what's really important about this is the air currents. You can see that it's along those. So the velocity of that air is 400 feet per minute. I don't think any one of us in here would select a diffuser doing 400 feet per minute. Just doesn't work that way. So once again, but this is a single room again, right? Single AC, we're in the space. So is that really still a full HVAC multi-zone unit? Another study came out, and this is one where they were trying to really, because a lot of the early things for infectious control really stopped and didn't look at HVAC systems. They looked at the grill. But this one they actually dug into, single room. They were isolation or quarantine rooms, and then they were taking samples. And you can see the viral RNA, meaning you would get sick from it, 71.4% of the filters had viral RNA on it, right? So So once again, single space, you are getting back into the HVAC system. We play a part. This one is from Omicron. I think this was before it was peer reviewed, and basically they were looking at individuals in a quarantine hotel and some individuals that were fully vaccinated and still getting the virus. So, and then the same individuals that did the hospital, the University of Oregon, did a study on a space where they were actually had people who were COVID positive, and they were adjusting in this control chamber. They were adjusting different activities and different things. There's other setups. And once again, they were seeing, and in there, they were looking at the filter impact or different air velocities, and they were seeing that it was having an impact on the space, right? So that's transmission. It's airborne. Yay, we're on the same page. So a little bit on the task force. This is an infographic that one of my coworkers created, Iman. So she took what I would put in a spreadsheet and made it into a really awesome graphic. It's actually got hot links. But we did this after we started having a lot of information. So the building guides, I lead the building readiness team, as I said. That's why it's front and center, right? I get top billing. But it's a way. And then the latest piece that came out was the core recommendations, which we're going to get into. And you would say, Wade, why did the core recommendations come out at the end? Well, we were trying to provide information. And then also we said, we got all these different groups working on stuff. We need to make sure that it's trued up and we're having a constant message about what the items are. And so we created this concise summary that actually took a lot more meetings than you would think, because typical ASHRAE, we started arguing over words and semantics and grammar. But we're going to hit these quick. First one is public health guidance. Follow it. ASHRAE is an industry, is a organization that deals with HVAC and R, not everything else. And so, in essence, the one we came up with was just follow that. A lot of you have seen this image, the NIOSH hierarchy of controls. A lot of what we do falls in this yellow bucket of engineering controls. The lower bucket is PPE. The reason that PPE is down on the bottom is because we've got a number of people in this room, but let's say you got an office building with 100 people. All 100 people have to wear a mask to get that effectiveness. But if I change my filter or change something with my HVAC system, everyone in the space gets impacted. And so that's why it's got a larger impact. Next section is ventilation, filtration, air cleaning, and basically outdoor air. It seems silly to have to state this, but let's at least have systems that maintain minimum outdoor airflow rates. We've seen a lot of buildings that don't have that. But so we needed to make sure that that was the starting point. And so this is one of those, early on it was, maximize your outside air if the space conditions will allow it. Well, a lot of people don't understand how do you determine space conditions allow it. And then you cut it off and they say, maximize 100% outside air. There's actually an article that still gets linked by CDC saying, hey, here's ASHRAE guidance. It's really the author's opinion, not ASHRAE guidance, where it says 100% outside air, run it 24/7. He wrote it in March of 2020, and he's in the middle of the country, middle of the U.S. I actually talked to him and asked, he goes, well, I mean, they need to make engineering decisions. You can't just do that. I'm like, So at the end of the day, no-brainer, code minimum. Then you get into combination of filters and air cleaners to achieve MERV 13 or better. And this is just trying to not say it has to be MERV 13. It's really meant to be a combination of different things because you have different ages of equipment. You have different types of equipment. You have equipment that can't have those MERV 13 filters. They just don't have the availability to get the air through. Yeah. Now, this is, imagine Dr. Bill Bonfleth standing on a soapbox because he keeps reminding people that it's code minimum outside air, MERV 13 filtration may not be enough for the risk mitigation in your space. So if you're sitting there and everyone in the room is exercising or playing musical instruments or doing something different or a higher likely where they're going to be in close contact, wrestling, etc., that may not be enough. So you might need to have more than just that. So use air cleaners for which evidence of effectiveness is clear. I really just want to skim over that. So then when you look at it and you look at your systems, because when you look at HVAC systems, I liken it to the auto industry, right? Motorcycles, cars, trucks, manufacturer, model, options. They seem infinite, right? So are our HVAC systems, right? So you need to look at what you can do, and you might need to include in-room air cleaners. Now, on the bottom, standard underlining of consensus risk reduction targets do not exist. What that means is ASHRAE actually tried to evaluate how much more of impact from filters or outdoor air would you need to target. And they were trying to do a standard 62 plus equation, right? And you graph all the lines and you can get the equation for the line. Well, they couldn't come to a common equation depending on the space types, and so they're still trying to figure it out. So ASHRAE doesn't have one. World Health Organization came out and said they want 10 liters per second per person in the space. That's 21.2 CFM per person in the space. It's really odd that that coincides with Hugo Lee's assessment, the one who had done the Guangzhou restaurant study, where he said, hey, we should have 10 liters per second per person in the space. So that's one of the targets. There's another one where Dr. Joe Allen from Harvard and Dr. Jimenez from University of Colorado, they did a spreadsheet that basically said, what in-room fan HEPA selection would you need for a classroom? And they've targeted an ideal of 6 air changes. That's their opinion. But in talking with Joe Allen, the basis of that really is ASHRAE Standard 170, looking at the different spaces and trying to figure out, well, if it's good enough for healthcare, then this should be our ideal for other spaces in a pandemic mode. We've already talked about this, air distribution, try not to have don't select your diffusers at 400 feet per minute. HVAC system operation, humidity and temperature. This one gets talked about a lot. A lot of people have seen that chart. Between 40 and 60%, there's less growth of different things, so we need to get to 40 and 60%. There's a lot of things with your building envelope. If it wasn't designed that way, you can actually cause a lot of other issues, especially in wintertime up north. But Lindsay Marr looked at this study, and she looked at this and said, okay, what if we do humidity on its own? It has a great impact. What if we do filtration and then humidity, or filtration and outside air and then humidity? And it's one of those things where it had much lesser of an impact, right? So I look at it as this. I'm not a small guy, so if I don't eat one M&M, I didn't have a dessert yesterday with the lunch, right? Great. I went home and ate a large pizza. Just not having dessert doesn't, so that, you have to look at all of it together, right? And that's what this study does. I'm not saying that it doesn't play a part, because the more humid it is, the particles stay bigger, so deposition happens at a higher rate, but when you factor in everything else, it has a much lower impact. When people are on the building, and by the way, maintenance, cleaning are people, you need outdoor air. Even if it's only 1 or 2, it may be just in a zone. The number of questions we got on this, well, what my night crew or my security guard? They're people, they're in your space, you need to ventilate. The flushing between occupancies, we'll talk a bit about that later on. I love this because I made a couple PhDs do a lot of pages of math to confirm everything. So, HVAC system operation, up in the top right, you see enthalpy wheels. There was an initial statement that said, hey, if your enthalpy wheels aren't working properly and they're causing leakage, turn them off. Well, in article, less pages, what it meant inherently was fix them because your systems need them and turn them back on. And so TC55, which is air-to-air or energy exchange for ASHRAE, came back and they had one sentence. If your wheels are well-designed and well-maintained, leave them running. And we said back, well, what's well-designed and what's well-maintained? So that one sentence turned into 29 pages for you to actually, and it shows you where to take pressure drop readings on the different sides of the wheel to figure out, is this acceptable in terms of leakage, and in reality, fix it. And then the other piece to think about this is, and you're seeing a lot more in the news today, where local water authorities are looking at the wastewater and they're looking at the counts, right? It passes through you, the virus does. So they can actually see the viral load in the waste stream. Which means that your plumbing vents and stuff, which happened, I think it was with SARS over in China, in the Southeast Asia, they had a lot of incidents with their high-rises where they were actually tracking it from plumbing vents into other building intakes and that cause of transmission. So just pay attention. All right. Hey, we all do this, system commissioning, yay. Definitely have to do commissioning on your systems. This is a study done by the government, US government, on K through 12, where it basically says that 50% of the systems are either past their expected useful life or they don't work, and so things need to be fixed. They also looked at envelope and windows and other things that get into it, but we've all been in buildings and seen stuff that really you wonder, how is that still running? A lot of deferred maintenance, and so let's get that done. All right, good. Skim through that. So, talking about some different strategies, right? It is multiple layer. There is not a silver bullet. There's never been a silver bullet in HVAC, so don't think there is one for here. Specific plan, space type, right? Thinking of, you've got classrooms that have different types of HVAC. You got unit ventilators, you got overhead air handling units with VAV. We've got a lot of units in the state that had DOAS and recirculation to a dual duct box. You've got barred units on all the portables, whatever those are called on portable units. But you have to look at the plan, you have to look at your system type, you have to look at how the space is being used, right? If it's pretty much empty, why am I worried about it? Hey, if it's a bunch of fourth graders that are doing art, or they're in a cafeteria and they're yelling and screaming, hey, there's going to be a lot more viral load. And then the bottom one is risk reduction versus install cost versus operating cost. So when you evaluate these, don't ignore energy. Don't ignore the cost of things. Don't ignore how long before I get that part in piece. So you want to look at your systems, air handling unit, you're looking at, when you're out there and evaluating it, you're looking for what you have, and then also, oh, by the way, what can we add? I also say to look at your water system. In the beginning, some of it comes to energy, but in the beginning, a lot of people were actually leaving their buildings and they were going, hey, we're just going to let it run, or hey, we're just going to turn everything off. And well, we had one client turn everything off, and in 2.5 months, the chiller fouled up, and they had to actually punch down the tubes because they didn't run the water. The water treatment went away. So just those sort of things. And that's more to think about in the future in terms of for the next one. Utilize your building automation system, just as we always do in terms of trying to diagnose things. And now we're going to get into some of the different strategies. This is Dr. Julia Keene with Kansas State used this to talk to the administration side of what classrooms should they use, what should they use and should not use. And this was her illustration for ventilation. In essence, don't throw the baby out with the bathwater. The little faucets are meant to be ventilation. You're still going to get not as clean air, but not as bad. But going back to that, can we increase the outdoor air? And I was like, yeah, maybe, let's look. So I called a friend and said, hey, can you select a 10,000 CFM unit, worst case conditions in Florida, typical water temperatures, et cetera, and lock in that coil, and then start ratcheting up your percent of outside air. What does that do? Well, I need about twice I can get to 90% outside air, and the coil would still be selected. It would allow it to be selected per their program. Twice the GPM, 2.5 times the pressure drop, and a lot more capacity. So it really comes down to, on chilled water, do I have enough chiller, or do I have enough redundancy in my system to even think about increasing my outside air above what it's been designed for? So in that case, that's the limiting factor, not the actual coil itself. DX is slightly different. Moving to filtration, it's why ASHRAE came out and said MERV 13 is preferred, typical. If you look at this virus and say, hey, at 1 micron, a MERV 8 filter is in the 30% range. A MERV 13 filter is in the 90% range. That's a huge improvement in terms of removing particles. Well, the virus floats around on particles, so if I remove more particles, then I'm removing more virus. But there's pressure drop and other things that are associated with this. But if you're evaluating this, find out what filter you do have, because chances are it's not on the existing drawings that tells you what was the dirty filter allowance. But find out the filter that was installed, and then look for a filter that's not that bad in terms of a higher rate or higher pressure drop. A key thing on filters, though, is how well are they installed? It's this study done by Dr. Siegel. This was a modeling version they did They've done 2 on-site testings of this that verify it, but the table's just not as nice, so I'm using that they align. But in essence, a MERV 15 filter with a 10 millimeter gap, less than a ½ inch, operates like a MERV 8. So how well my filters are installed is more important. What I recommend to owners, and I see some tab guys in here, is, hey, why don't you think about doing an integrity test? If your guys are changing out your filter, if your team is changing out filters, have them change out the filters and do an integrity test so they can see how well they're actually doing it. We've all walked up to spacers on the roof and missing filters and damaged filters, etc. But that's a way that you can actually train the staff to do better in terms of filters, because it does have a big impact. So, second question, to achieve the same level of risk reduction, right? We're not saying, hey, it's safe. We're reducing risk. Does increased ventilation cost more to operate than increased filtration? Everyone got their answer locked in? Well, lo and behold, a study by Azimi and Stevens, and they looked at this, and it's like 2013 range, so these are different costs, but from a standpoint is you've got mean relative risk on your left-hand side, you've got the annual cost across the bottom, the gray line coming down is your filter, hey, MERV 13, kind of that point of diminishing returns, but then you have different cities, different weathers. We would call us Houston, and so at a MERV 13 level, you can see I'm under 200, but with outside air to do the same impact, I'm 580. So this is where ASHRAE is saying is, think about your operation. If I was in the Northwest, right, because you don't see any Northwest cities here, right? They're a lot more moderate. I might be able to do a lot better with outdoor air a lot of times of the year. So it's making sure you think about it. For in-room air cleaners, look for the rating, CADR. That's how much clean air you're getting. Placement's important. For the air cleaning in the ASHRAE guidance, it gets into UV and looking at it. There's other air cleaning that you can use. I just want to touch on the fact that you see it in the downstream of the coil, and then you see it in the supply duct. And UV is like a birthday candle or on a blowtorch, right? It's time and intensity. So putting it in the air handling unit, I've got a lot more time because the air is slower. But, you know, Amy would wave her finger across a birthday candle and not get burnt. But if she held it there long enough, she will get burnt. She's not putting her finger across a blowtorch at all, right? So it's a balance. Now, as we talked with filters, different performance, different levels, you have to add them up. You don't need 99% inactivation by UV. Filters and UV, you'll see later, play against each other. This should really, so flushing with equivalent outdoor air. Equivalent outdoor air, really what that is in Wells-Riley, they call it clean air. You see it in other places. This is air that we're assuming that we've removed the virus, and it's not just SARS-CoV-2, any virus. And so we're trying to be predictive on using that air to help flush between occupancies. I liken that to the time frame we're talking is between movie times, right? You walk into a movie theater and the last movie just left and it's stale. That's the time frame where you want to try and hit this to really remove virus. So the equation is actually pretty simple. We're just looking at air changes, effective air changes of equivalent outdoor air. You have straight outside air from my filter, from my air cleaner, and from anything in the in-room. You look at the air handling unit diagram, I have filter first, and then I've got UV second, and that's important, and you'll see it later. So for my outside air, that's pretty standard. Greg's given me my reading of my unit. I know exactly how much outside air I have because everything is certified and calibrated, and you basically can calculate how many air changes I get. Pretty straightforward, right? With filters, I'm only using recirculated air, and what do I really need to look at for that? Well, we said, what if we could be a little bit more predictive on what the filter can do just instead of just particle sizes? Where is that viable virus, right? At the time we built it, there was very minimal on SARS-CoV-2, there still is, but there was a lot of research done on influenza A. And in essence, these guys, Stevens and Azimi did again, is they compiled all of these studies that evaluated where those particles were. Now, I should have highlighted it, but what's great is they were able to get the study data and they put it into ASHRAE standard 52.2 buckets. So the micron size. So these three columns are the different size ranges for 52.2. So now, if I've got a percent of where that filter in each one of those buckets can pull from, I can actually get a single value, right? And what they referred to that is filter droplet nuclei efficiency. Really easy term to remember. The results of their study was 20, 29, and 51 as smallest particle to largest particle. What we did is we got filter data from 180 filters that are on the market, actual performance, in what they've published, how they meet with 52.2. And so now you can just basically take each bucket times where you expect the virus to be to get a single value for how my filter's performing. This has been recently updated. We had to turn this in early enough. We've recently updated this because there's two or three studies that have come out on SARS-CoV-2. One is Dr. Milton and Shelley Miller did one on instruments in the space, but they only looked at greater and smaller than 5 micron. There was another one that came out that used less than 1 to 4, greater than 4. And we actually got the data and analyzed it and looked at it and looked at their standard deviation. And they disagreed with each other, right? They weren't exactly saying, here's the right bucket. The only thing that they all said was the majority of the viable virus on the particle sizes, the greater percentage was less than 5 micron. So if you go to this Google sheet today, you'll see these numbers are here off to the side, but there's some new information, and so it's 30, 30, and 40 to prioritize the lower ranges. Now, if you want to be really conservative, because you just don't believe that, hey, you can predict that, then make that E1 bucket 100%, because that's the worst performing part of your filter. But you can actually, so now if I know how many particles my filter is going to remove, and I'm assuming equal distribution of virus in those particle sizes, I can take that, multiply it by the recirculated air to get the equivalent outdoor air going in my space, and I can know the air changes from it. Now for the air cleaning device in the unit, this is where the order becomes specific, right? So if someone uses and says, hey, I've got UV and it does 80%, and you just picked a filter that does 70%, great, I'm removing 150% of my particles. It's just not physically possible. So the order is important. So essentially you have to take what's left after the filter and then what the air cleaner would do upon this. And this is why I said they can play off of each other. If they're in the reverse order, you need to reverse the calculations and look at it that way. But in essence, you're doing the same recirculated airflow, inactivation rate of what's left after the filter, and get you those. So this is the math that gets into why we picked 3. I'm not going to get into this, but in essence, when you look at this, this is one where I had a couple PhDs doing a lot of math. At the end of the day, if you do 3 air changes, you end up left with 0.05. Now understand, this is from steady state, meaning no one's in the space, right? You're not producing any more, so it's how long does it take to remove it, and 3 air changes. Now you say, hey, I've got a much more aggressive space that I want to protect better. You might go 5 air changes, but you can see it's not as great of a difference from 1 to 3, right? So you got to balance your energy in what you're doing. Now once again, between occupied periods, not necessarily end-of-day flushing like we're used to. So this is the data that's shown in the sheet. The calculator, you're putting in anything blue. So this is a middle school classroom that we evaluated, 9-foot ceiling, supply air, outside air, that is code minimum. And then you can see we changed the MERV filter, and that's pulling from that table that we showed. We have UV with a MERV 8. It does all your, so you can see each component, but it's saying your effective is 9 air changes of equivalent outdoor air. MERV 13 with no UV, no in-room, I'm at 7.5. MERV 13, I can add 150 CADR from an in-room, and I'm back up at 8.6. So you can see that it's not one solution. It's not just one filter size. It's just not one technology. And because this sheet is for flushing, you can change your air changes per hour, and it's telling you your time. So now the documentation started with 2 hours pre and 2 hours post. That was early. That was early on. Then we went to 2 hours pre or post. And now we say if you don't do these calculations, 2 hours. 2 hours comes from those units that have their outside air damper shut, so you're getting a little bit of leakage. And you have like a MERV 4 filter equivalency, and so that's like an hour and a half, hour and 45. So conservative engineers just make it 2. This is available. You can do your calculations. Now, where your systems are operating plays a part. It does with any air cleaning, any technology. So if I'm operating at minimum airflow, so you might want to look at your trends to figure out where you really are. This is a lecture hall at a university, and the actual numbers from their air, and at minimum, they're essentially 100% outside air. And even though they have MERV 13 filters, at max airflow, they're doing 12 equivalent air changes per hour, which is really great. At minimum, they're doing 3.36. So where's your system actually operating? You can't just assume that it's at design, because we all know engineers have a lot of safety factor. So you evaluated your building, you've looked at all these different things. This talks about having a building readiness plan. This is the document to communicate what are you going to do. You need to work with the owner on this to come up with what they're actually going to implement. You're going to have a larger list of what you suggest, but the building readiness plan should really be down to what are they going to do in their facility. So let's look at some example projects. Yeah. You see the nice little water line here? They had some issues in this space, so who knows how well the air quality is. So we've done a few projects for this. This is a college in Florida. They actually had a really good maintenance program, and their teams were on top of it, a bunch of different campuses, and so we went down and we actually evaluated their systems. And this is where I'm going to say is, don't ignore energy, right? You're there, you're evaluating it, benefit your owner, help them with other things. So this was a variable primary chilled water system, 2 chillers, 2 pumps, 2 towers. You had 1 chiller running. I'm doing a 2.4 degree delta T. This chilled water pump is at 54.2 hertz, which is about 90%. So why am I flowing 90% of my water when I only have 2.4 degree delta T on a 12 degree delta T chiller? It doesn't add up. We did check the bypass. It was closed. So when we're out there, we're going to have to pay particular attention to every valve to see why it's not working, see if they're left manually open or broken or whatever, because we've got a lot of flow through. The other thing we looked at is these cooling towers. It was cool. They were running both. Good job. But they were running at different speeds. So one was full out and one was at slow speed. You can save some energy. It's an easy thing. Easy programming fix for a few hours to actually help reduce your energy over the year, right? Nothing to do with COVID. But while you're there, tell your client. Help them. So this is one of the air handling units. A lot of their air handling units actually had a 100% outside air coil. All those valves were just forced open. That's where the low delta T was coming from. So when you start to look at these, and color is bad, but so this is my airflow measuring station, and it's 36. I can read it better here. 3,600 CFM. And down on the bottom right is my outside air CFM set point of 1,000. My return damper is wide open. My outside air damper is where? Why am I'm over ventilating, or my airflow measuring station's out of calibration. But nothing's happening. It just sat there. And so that's one of those, hey, it's great that you have more outside air, but you really do want your system to work properly. So let's identify it as something to fix. One of the other ones that I love is every unit we looked at, right, Marcus? Every unit we looked at was 1.5 inches of duct static. For those of us that know, that's basically the number means it didn't talk to tab and didn't get a real value because it works. So little things that you can help your owner. So this is the actual units where they had the outside air coil on top, the return coil on the bottom, met and went out, and we started to look at this unit. So you can see picture of the outside air dampers. They don't look that bad. They were open, so it correlated with the BAS. Some of their units had little outside air fans that you can see on the top right. And then the exhaust fans, because we're evaluating a system, not just an air handling unit. And the note on the bottom one is, I think it says, leave run all the time. Well, so guess what? When you turn the unit off, you're going to have a negative building, other issues, something you might want to point out. Looking at the unit, we looked at the filters. 2 issues. And this is actually in the direction of airflow, left to right. This filter is a little tougher to see, but it's crushed in, and you're not really going to get the right airflow through it, so you're impacting it. And the fact that the filters are in backwards is not a huge deal. We confirmed with them that they weren't just turning them around, so that was okay. Another project we worked on was a school district. This one was interesting because they had asked us prior to COVID to help them with equipment condition, anything 5 tons and greater, to look at. So we actually had a really good handle on the equipment they had in their buildings. COVID hit, and then they started saying, hey, we're getting some funding. Can you please help us? So the funding they went after was for UV as well as filters. And so we did some evaluations. We also looked at ventilation. So what they ended up with is, because, like I said, we had a good knowledge on their systems and it was a lot of deferred maintenance, we said, use a MERV 9A filter because all of your equipment will be able to run on that. And then they also evaluated UV. We looked in cafeterias and auditoriums. And some owners do building by building, but what they said is here's our higher risk spaces, and so we're going to evaluate those in a different bunch of schools. And then so they ended up installing a lot of UV and the filters. The other thing we found at two of the schools we went to was heat pumps with a closed circuit tower, and the outside air was just not treated at all. And so they basically had shut them all off because those units really can't handle a lot of outside air. So they actually added 2 DOAS units to schools so they could actually have outdoor air in the space. And then this one was a large university in the southeast. They looked at a few different strategies. First thing they did when it came out is they disabled demand controlled ventilation. Following what ASHRAE said is, hey, trying to minimize that, get your outside air. But then they turned everything into 24/7 flushing. They were reading that article by an individual and they turned it that way. They did calibrate their outside airflow measuring stations because they knew that it was a key component. And then this last one was carbon dioxide monitoring. One of the individuals was quoted in an article, this Dr. Jimenez, basically saying is, you should target to have 700 parts per million of CO2 in all of your spaces. So our client, it finally trickled down to him because it ended up from the state and it got up to the point where the state then mandated it for all government facilities. So at the end of the day, I had another slide in there that was, that escalated quickly. Because basically, to try and do that for an existing campus of its size, to have every space hit 700 CO2 when operating with people in it, would require just a crazy amount of money to alter all those systems. Yeah, so there it is. Florida Surgeon General to the Chancellor, to all Florida University presidents, to the provost, and then my client got called saying, hey, can we do this? And yeah, I got a phone call, right? That was his interpretation of what really went down. And so we actually were fortunate enough to talk to Dr. Jimenez and get an email back that basically said is, no, I mean, that's maybe moving forward, but not in every situation. And however, they also evaluated their filtration. They had an empty campus in the beginning of this, and they had a lot of equipment. So they looked at their before COVID, their standard 2-inch MERV 8s with 4-inch MERV 10s, and a clean pressure drop of 0.6. So they said, let's do a couple different setups. 2-inch MERV 9 pre, 4-inch MERV 14 final. That's 1.1 inches clean. That's a no-go. The test setup number 2 was 2-inch MERV 9, 12-inch metal frame MERV 14 final. That's a 1/2-inch pressure drop. That was pretty good. But after doing a number of units, they actually had technicians saying, hey, these things are heavy, and by the repeated motion, I'm going to file for workman's comp because I can't come into work because I'm hurting myself because they were doing so many units. So they said, all right, we got to come up with another option. Someone said, do we really need the pre-filters? Can we just look at MERV 14A bag filters? And so they actually operated one in their building for 6 months, and it was still relatively low pressure drop. And they said, yeah, that's likely to be their standard moving forward. It just depends on when that gets put in. Now, one thing I'm going to point out, MERV 8, MERV 10, and then you'll see the A. The A rating is a different rating of a filter. It's important in places like Florida. Humidity plays a part in that filter's operation. When it's just a MERV 9, it's got an electrostatic charge on it, right? When you shock your hand on the door. Well, that attracts smaller particles to make them bigger. So when they test them, they perform better at the lower numbers, so these filters look like better filters. A MERV 9A filter, they actually discharge the static before they then test the filter. So you are getting the true uncharged filter performance. So I would highly stress that you look at using MERV A rated filters depending on where you're located. So they actually had a chart of everything. It was really nice. Tried to lop everything off to keep them, like I said, large Southeastern University. But they actually started to keep track of what filters they put in where so they could understand what they needed to buy. It was a supply chain issue as well, trying to make sure they had everything. But they documented what they were able to do with each of these units. They also looked at UV. They knew that they had a lot of equipment to deal with, so they settled on 3 different manufacturers. They went with the intensity for SARS-CoV-2, and in essence, they were able to upgrade 216 air handling units. Well, half of them have UV, and then they all have the MERV 14 filters. So in their mind, they've got it covered. Now, when we looked at that chart, that filter and the UV can play off of each other, so they might have at a higher level. But this is one of those where people ask, well, is there going to be another one? And so in January of 2020, ASHRAE Winter Conference was here in Orlando, and I was on the Environmental Health Committee. And someone proposed a session just like this that said, SARS, Ebola, swine flu, what's next? Like a legit, and these are more on the health side of things of, it's coming, there's another one. They haven't hit the US like we have. So if you go back and look, the rest of the world has been hit. So in their mind, yeah. Quick discussion. I don't know where I am on time. We're getting, I want to leave time for Q&A if there is any. So something that we looked at and we're evaluating to help owners with is actually using fault detection and using more diagnostic tools to try and be more predictive. So CO2 is, a lot of people say, I know how much outdoor air I'm getting if I have my CO2 readings, which is true, except for you're dealing with virus particles. So 10 people in a room has the same CO2 level if 5 are infected or 1 is infected, or none are infected, right? So I don't actually know the viral load I have in my space. I just know that I'm doing pretty good flushing with my outdoor air if I've got a low CO2 level. Okay, so let's look at then measuring something like PM 2.5 or PM 10 or VOCs, other items that would then start to tell you how many particles I have in my space. Because if I've got a good CO2 rating and I've got a low particle count, chances are I've reduced the risk for the occupant in there based on being able to contract any virus. Now, a lot of this has been about virus, but those that in Atlanta, when the pollen season hits and your car turns yellow after every day, if you wash it, because there's so much pollen in the air, this is something that actually could help you, right? In those time frames, you might be able to use the outdoor air and the indoor to make sure that you're providing a safer environment, or the wildfires out in California, right? So you can start to use these to be predictive. What we initially talked about was, could we help with the flushing process? Because if we hit targets in the space, we could save energy by, let's say, this conference room is, I'm going to call it half full to make myself feel better, but half full. Well, if it was only a quarter full tomorrow, do you need as much flushing time because you might have less particulate, less stuff to do? So you can actually be predictive to save energy. And this is just using a CO2 sensor, which don't blow directly on them because it invalidates it. But in essence, you can use that reading. You can use the PM 2.5. You join it all together and you look at it and you can start controlling your systems and start being predictive of what you're doing as opposed to just assuming I've got my right outside air, I've got my filter, and I'm good. There we go. That's that. So at this point, we got time for some Q&A if anyone does have any questions. Marcus here has a mic. If we've got no questions, we can all, we got a question in the back.
I'm in a contract right now with the GSA test hundreds of buildings in the country. And the guideline that the GSA is using is ASHRAE 62.1 based on the CDC. And I've got like 12, 15 engineering teams with TAB partners to be able to measure all of these air handlers in every one of these buildings. 60% of them are failing.
Yeah.
One of the risk factors you showed there is, between filtration and outside air. And you made a good point that it depends on the region in the country where it would make sense.
Correct.
So with the GSA saying that no, this is the guideline, it's fixed, is that a concern?
Yes, because they're making everything be the same. The other thing I'm going to point out, and I'm a big ASHRAE guy, but not every organization has their little glitches. So Standard 62, that's your guideline. What's the title of Standard 62? Ventilation for acceptable indoor air quality. What's acceptable? Is that meant for this time frame? Is that meant for the next epidemic? It's meant to be, people aren't really going to complain about it, and so that's a good enough value, right? And so ASHRAE is actually in discussions to figure out, just like they have standard 90, which is the minimum, and 189, which is a high performance, they're trying to figure out how can they build something that is ventilation for good, better than acceptable, right? Because acceptable is a really murky word just to begin with. So I would say it's good that they're doing it. It's great that you're using tab technicians as long as they have the right qualifications and their instruments are calibrated, because you're actually getting readings, right? If you're reporting this to your owners, you want valid readings. I can take measurements, but I see guys in here that have done it, I don't know, 1,000,000 times, and I would trust their readings more so than mine because all the different nuances that you learn over time. So that part, what you're doing is excellent. But if, at least they're hitting a bar, right? And if they can get all the buildings up to that bar, then they at least know where their buildings stand in terms of outdoor air. But yeah, I would think that in certain areas, like here, you would say, okay, great, I'm going to hit that target. I might be able to go more, but if I was in the Northwest, I would, I want to not just see it at design, I want to see how much more I could push because I have a lot more hours that I can use. Whether I've got air side economizer or not, I can actually increase for no or minimal energy penalty. Does that answer your question? Okay. Any other questions? You guys let me off light.
Oh, we can't have that. I have a question, sir. I see in the study that you guys used the ultraviolet light as one of your means for purification. Were any other means like bipolarization, cold plasma, was that investigated as well? And if so, is it worthy of
Thank you.
Your friends and coworkers are supposed to give you softball questions, not ones that are difficult to answer. So that's a very interesting question. So I'm going to answer it two different ways. One is as an ASHRAE board member and as a member of the Epidemic Task Force. I'll give you that perspective. There was a lot of different technologies. We all on the task force got a lot of phone calls and, hey, I've got this product. More than what you mentioned. And so the filtration and disinfection team, led by two individuals, one who operated a air testing laboratory for 30 years, started evaluating all the documentation they could find to find peer-reviewed research, et cetera, X, Y, and Z that had enough findings, right? And when you talk to researchers, 3 papers that have been peer-reviewed is still not enough. They want more proof than that. And so what ASHRAE ended up with was, we're not going to, UV was proven through tuberculosis, through its time. It's got an actual method of test that you can actually evaluate, different manufacturers, just like miles per gallon, right? If you rode your motorcycle down here, you got much better miles per gallon than I did, but we can compare them because it's a standardized test. And so we looked at, do they have a standardized test? A lot of them do not. They're newer technologies, but that sort of needs to be developed so that you can understand the readings. So what ASHRAE said is to not say don't use them. What it said is you as the engineer of record have to use your judgment in the evaluation of the information that you've received, and does it make sense for your situation? And a lot of people took that to mean, no, don't use it, but it truly is there's not enough independent research data to say, this is a direction to go. And so bipolar ionization is one we get a lot of questions on. The photocatalytic oxidation. There was one where they had a filter in the return airstream that they were alternating current to make it 200 degrees. I actually got to talk to those individuals, and so I asked, well, where does the heat go? because at 200 degrees, it's going to go into the airstream. So, and they said, oh, it's none. And I'm like, do you mean negligible? Like, I'm giving you an out. And they said, no, it's none. I said, okay, what kind of heat sink are you using then, like on a computer? And they're like, heat sink? We don't have a heat sink. There's just no heat added. And it was like, okay, well, something doesn't, the physics don't seem to work there. And so, and I can't, I'm going to use it, and I apologize. Dry hydrogen peroxide manufacturers now trademarked that term, and I don't know what to call it other than not the stuff you use to clean vivariums, but at the end of the day. What's that? Thank you. Appreciate that. Gaseous hydrogen peroxide. And so once again, there's nothing. So what ASHRAE did is they've actually formed a technical committee for, it's like RAST, or I forget what the acronym is, but an intent is to air cleaning technologies to create a group to start to have that, and then they created a standards group alongside to create a method of test. So the hope is that we're pushing forward to be able to have something that all the manufacturers can then test against and say that, hey, these work and these will be great, but right now, not willing to. Me personally, I've looked at a lot of these, right? So this is now Wade, Conlan, individual, not ASHRAE. I've looked at a lot of research and fortunate enough to have good relationships with a lot of the different vendors. And so every single paper, everything that's come out, I've actually sent questions. Said, hey, I've read this. This seems to be a really high velocity in the space. This seems to be something different. What am I missing here? Why do you, like I asked about the heat sink. Or why do you have fans? Oh, it's to replicate body heat. Okay, well then can we do something that's more realistic? And so I continue to ask for my own personal knowledge of how does this apply to my space, my system, what I'm looking at, what I'm evaluating, because I would love to find something that has a phenomenal performance against any virus or any aerosol. But, right now I'm sticking with tried and true. Long answer, but trying to be both hats, but at the end of the day, it becomes down to your evaluation. So, any other? All right.
All right. From the research you've seen or done, is it a good idea to open up the outdoor air during morning warm-up, or is that a determination that has to be made like on a case-by-case basis?
So in the beginning, we said, yeah, you should do that, even though you normally don't. When you do morning cool down or morning warm up, you typically leave your outside air closed because it saves energy. Not sure exactly how much. Maybe someone modeled that at some point, but it does save energy. And so at the beginning of this, it was more of, yeah, go ahead and do that. That was part of the flushing before we started really looking at it. And not looking at it, but saying, okay, hey, conservative principle, this is where we're going to start. But then when you start to look at the virus and the deposition, right? Deposition meaning when it falls out and falls to the ground. Well, if my building is unoccupied from 5 a.m. till 7 a.m., I probably don't need to open my outside air. But if I'm looking at a 2 or 3 hour window, do the calculations that we showed with the equivalent outdoor air calculator, but do it with your outside air and see how long it would take. And that might be enough time, depending on what you have with the rest of your system. So it is a case by case. But like I said, in the beginning it was, yeah, do that. And now it's more okay, there's other factors. And the equivalent outdoor air calculator doesn't take into account deposition. Standard conservative engineer, right? You'll get better benefit, right? I'd rather, was it under promise, over deliver? So hopefully that answers your question. Any others? Hearing none. Once again, thank you very much for coming today. Don't forget to go into the app to check in and make sure that you get your PDHs. And if you want to give a favorable review, go ahead. I would appreciate that. If it's unfavorable, just come yell at me afterwards. But with that, thanks for your time. Appreciate it.